Hi there and welcome to our lesson 4 in our C3 chemical economics topic. Now we're going to be looking at masses and reacting of masses today, all to do with industrial chemistry and chemical processes. Anyway, I will pass you on to our objectives. Okay, so by the end of our lesson today on reacting masses, you should know and understand how the laws of conservation of mass are followed. Okay, now what we're going to do is we are going to look at what the atomic mass is. Now we're going to start by looking at an example of an atom by looking at the periodic table. Now we're going to go through two of these to start with so that we can get a good understanding of what we are talking about when we refer to atomic mass. Now here we've got an example of sodium. Now when you look at the periodic table, this is the information you get about sodium. Now here we've got the name, sodium, and then the symbol above it, which is Na. Now here and here we have two numbers. Now this is what we call the atomic number, and this is what we call the atomic mass. Now it's quite often referred to as the RAM, which stands for the relative atomic mass, and it's been given AR as its symbol, which is relative and then atomic mass. Now this is the mass relative to every other element. So if we looked at another example, such as oxygen, the relative atomic mass here is 16 as compared to 23. Now, it just means that it's relative to each other. So if this was 8, which is the mass of an isotope of beryllium, then it would be half as heavy, or the oxygen would be doubly heavy. Now, the relative molecular mass, or the relative formula mass, is the mass of a molecule. Now a molecule contains more than one particular atom. Now what we're going to look at is how we can actually work that out. Now what we need to do is look at an example. So if we look at sulfuric acid, which has the formula H2SO4, we can see that the 2, which should be a subscript, but unfortunately I can't do this on this particular bit of software, means we've got 2 hydrogen atoms. Because there's no number next to the sulfur, we only have 1, and then we have 4 oxygen atoms. So what we can do is we can look on the periodic table and we can find the relative atomic masses of hydrogen, sulfur and oxygen and multiply them by the number of atoms that we have. So here we go, we've got the maths that we've done. Okay, so we've got 2 hydrogens, which has a mass of 1, which even without a calculator we can work out as 2. We've got the 1 sulfur, which has a mass of 32, which equals 32. And then oxygen, which has a mass of 16, and we've got 4 of them, will equal 64. So when we add up the relative masses of each of the elements and the number of atoms that they have, we get a value of 98. So sulfuric acid has a mass here of 98 grams relative to other molecules. Now we're going to do a second example here, which is slightly more tricky. Now we're going to look at calcium hydroxide. Now if we look at the formula of calcium hydroxide, we've got no number after the Ca, which means we only have one of the atoms. Now here we have a bracket, and then outside the bracket we have a 2, which means we've got 2 of everything inside the bracket. Now this bracket could be a 2, it could be a 3, occasionally it may be a 4, but that's very, very rare. So let's have a look at the maths to add these up to see what we get as our relative molecular or relative formula mass. So here we have the mass. We've got calcium, which has a mass of 40, and we've got one of those, which equals 40. Oxygen, which has a mass of 16, we have two of those because of this 2 outside the bracket. So 2 times 16 is 32. And then hydrogen, which has a mass of 1, and there's 2 of those, again because of the bracket, equals 2. So when we add all of those up together, we then have a relative molecular mass of 74. Now, what I'd like to do is pause the video and see if we can work on a problem. So pause it in a moment. Okay, so what is the relative molecular mass, MR, of ammonium sulfate, which has the formula NH4 in brackets 2 SO4. Okay, so pause the video now, work out the answer, and I will be back in a second with the answer. Okay, so welcome back. I hope that you have the answer of 132. Now, I'll just explain how we work that out. We've got nitrogen with 14, hydrogen with 4, but we've got 4 of those, so together they add up to make 18. We multiply that by 2, which gives us a value of 36. Sulfur is 32, and oxygen is 16 times 4 is 64. Add the 36, the 32 and the 64, and we end up with 132. Now, the conservation of mass is exactly what it is. It means that when we have a chemical reaction, all the mass on the reactant side is going to be exactly the same on the product side. So the mass of the reactants is equal to the mass of the products because nothing is added in and nothing is gained. So what we're going to do is have a look at a couple of examples. Okay, so here we have nitric acid, which is HNO3, reacts with ammonia to make ammonium nitrate, which in our last topic we know is a fertilizer. Now, what we're going to do is calculate the mass of the reactants here and then calculate the mass of the products. Okay, so the mass of our reactants here, HNO3, is we have 1H plus the mass of 1 nitrogen plus the mass of 3 oxygens. Then we have ammonia, which here is 1 nitrogen plus the mass of 3 hydrogens. So 1 plus 14 plus 48 for the 3 times 16, it gives us a value of 63, and then the 14 plus the 3 times 1, here 3 gives us 17. Now if we add those together, we end up with a mass of 80. Now for our mass of our products. So the mass of our products here, we've got the formula NH4NO3. So we've got 2 nitrogens, then we've got 4 hydrogens here, and then we've got 3 oxygens here. So 2 times 14 for nitrogen here is 28, plus the 4 times 1 for the hydrogen is 4, plus the 3 times oxygen is 48. And that gives us a total of 80, which is equal to the mass of the reactant at the start. Okay, so we're going to have a look at a couple of slightly more tricky examples here. The first one we're going to look at is the combustion of propane. So we're going to put the chemical reaction on. So we've got C3H8 plus 5O2 goes to 3CO2 plus 4H2O. So we can work out that the mass of the propane here is 44. Okay, so that's 3 times 12, which is 36, plus 8 is 44. Then we have the mass of oxygen, which is O2, so that's 2 times 16 is 32. Okay, so we're now going to make the carbon dioxide. Now the carbon dioxide is 1 carbon, which is 12, and 2 oxygens, which is, let's see, 44. And then we've got a water here, which has a mass of 18. Now we can see here quite clearly that we've got a difference in the amount of mass of the reactants and the mass of the product. So if we total up the reactants, we get 76, and if we total up the products, we get 62. So this doesn't add up. But if you notice, we've got 5 lots of oxygen, so we need to multiply this number by 5. So we then come up with 44 plus 160, which is equal to 204. We've also got 3 times carbon dioxide, so that will give us a value of 132, and we've got 4 times the water, which gives us a value of 72, which when we add those together we end up with, guess what, 204. So that's how we end up with our reaction of the mass of the reactants is equal to our mass of the products. Now our next example we're going to look at is calcium carbonate, which thermally decomposes to make calcium oxide plus carbon dioxide. Now I'm going to cut out a couple of stages here. Okay, now the mass of calcium carbonate is 100, and the mass of the calcium oxide is 56, and the mass of carbon dioxide, as we saw in the last example, is 44. Now this tells us that the 100 mass of calcium carbonate will give us 56 grams of calcium oxide. Now in terms of our ratios, it can mean that if we have 100 grams of calcium carbonate, we will end up with 56 grams of calcium oxide. Now this means that we can multiply this and work out how much calcium oxide we are going to get whenever we have a amount of calcium carbonate. So for example, if we had 50 kilograms of calcium carbonate, we would produce a ratio of 56, which is the mass of the product, over 100 times by the 50 kilograms to tell us how much of the calcium oxide we're going to make. And in this case we're going to make 28 kilograms of calcium oxide because of this ratio. Okay, so I hope you have enjoyed this lesson. We have looked at what atomic mass is, we have looked at what relative molecular mass is, and we've looked at a couple of examples of the laws of conservation of mass. Anyway, I hope you've enjoyed this, and I will see you next time. Bye bye.